Welcome to this introduction video on Blue Demon's E6013 arc welding electrodes. In this video, we will discuss some of the details of this electrode, some safety concerns and how to deal with them, and a short demonstration of the product. E6013, or more commonly termed 6013, is used in the process called shielded metal arc welding, or SMAW. However, that process is better known as arc or stick welding. This process uses electrical current flowing through the electrode and workpiece to fuse the two together. During the flow of electricity, the electrode and workpiece become molten where the two meet. When these two molten metals flow together, they create a very powerful bond to one another, thus forming a weld bead. One of the first questions you may have about this electrode: what does the letter and numbers mean? Welding wire and rods are classified into different types of filler metals. In our case, the classification is E, which stands for electrode. Other types of classifications could include ER, electrode or rod, R for rod, or B for brazing, just to name a few. Next, we take the first two numbers, which in our case is 60. This is the tensile strength of the filler metal, given in pounds per square inch, or PSI. You can take the 60 and multiply it by 1,000, thus giving you 60,000 PSI of tensile strength. The third number indicates the welding position of the electrode. This could be a 1, 2, 3, or 4. The 1 would indicate the electrode will perform in all positions. The 2 indicates a horizontal or flat position. 3 is an older term meaning flat only, however, it's no longer used. And finally, a 4 would indicate the electrode can perform in flat, overhead, horizontal, and vertical down positions. In our case, E6013 will perform fine in all positions. And finally, the last number indicates the coating or flux and electrical current used by the electrode. Valid numbers for this position are 0 through 6 and the number 8. I'm not going to cover all of this information here. However, a quick Google search should produce a chart for you to study. Per the chart I have, E6013 is a titania potassium-based electrode that performs well using AC, DCEN, or DCEP. 6013 is also categorized by another factor. It is a fill-freeze type electrode. This means it has a higher deposition rate and the weld pool solidifies more quickly than some other electrodes. I typically get a lot of questions about the coating or flux. What is it and why is it there? The flux does several things to help make a great weld. It provides some of the alloying elements needed. It can also provide an arc stabilizer, although this is optional in the manufacturing of the products. The flux also serves as an insulator, so if you touch the side of the electrode to the workpiece, it doesn't arc. The slag formed by the flux protects the weld bead from the atmosphere and promotes a slower cooling rate. Last but not least, the flux creates a plume of shielding gas to protect the molten pool of metal from the atmosphere. 6013 is a pretty common electrode and is a general purpose electrode. Some of its main uses are sheet metal fabrication, metal buildings, surface buildup, and farm equipment. Let's stop here for just a moment before I begin the demonstration portion. We need to talk about safety. The welding process can produce harmful light, fumes, sparks, and flying slag, just to name a few. You should always wear the proper clothing and safety gear while welding. This includes, but is certainly not limited to, a welding hood, welding jacket, or long sleeve shirt. I would suggest cotton or wool, as synthetic materials may melt to your skin. Next, select a proper thickness of gloves, ear protection, and safety glasses. One should always wear eye protection during the welding process. Here's a tip. Many welders will wear a small respirator, like the one seen here. It filters out some of the harmful things floating in the air. The other thing it does is direct the hot air you breathe down and out of your hood. If you've ever welded before, you know the lens can become so fogged you can't see anything. Now that we've covered the safety portion, I'll set up a few test coupons and run a few beads. The machine I'll be using is Blue Demon's E6013 STI. This is an inverter style machine that can TIG or arc weld. The amperage range of this machine is 50 to 160 amps with a 35% duty cycle at maximum output. Please keep in mind I'll be moving the camera around for different shots, so you may notice subtle changes throughout the demonstration. I'll be right back after I get my gear on. Anytime I'm going to weld anything, I always find a scrap piece of steel to pad beads on. This gets my hand-eye coordination back in sync so I can run the best bead that I can. I'm not a welder by trade, so I really need all the help I can get. Things I work on when padding beads are electrode angle, travel speed, distance from workpiece to electrode, heat or amperage selection, and if I need any type of electrode manipulation. For my angle, I typically try to stay more upright. The textbook angle to shoot for is somewhere between 10 and 30 degrees. When I'm welding my best in the flat position, my electrode angle is around 10 to 15 degrees. For quick reference, I keep a chart next to my welder in case I forget these details. Next, travel speed is something you'll need to test and examine for yourself. You'll want to make your weld bead not look so flat or wide or narrow and tall. You should be able to quickly and easily find some examples of great looking weld bead profiles on Instagram or YouTube. As for distance to workpiece, you'll want to hold a very tight arc. The textbook answer for this question is the arc length to be the same as the core of the electrode you're using. Many welding troubles can be traced back to not holding a tight enough arc. Something I struggle with is keeping the arc too close. This can cause the arc to go out and/or stick my electrode on occasion. What I try to do is touch the workpiece with the electrode. Then I'll lift it up off the plate just enough so I can see some light shoot out in the direction that I'm welding. This was explained to me one time long ago, and it has really helped me ever since. For my heat or amperage setting, I keep a chart with my welder for quick reference. Based on the electrode size and thickness of material, it's fairly straightforward to get the setting in the ballpark pretty quick. And finally, rod manipulation is really a broad subject. This could be a weave when you're moving your electrode down the workpiece and moving it from side to side. Or you could just use some type of whip and pause motion like you might use for 6010 or 6011. In the fabrication work I do, I typically want to run stringers or straight beads. With 7018 or 7014, I'll run straight down the joint with no side-to-side movement. If, however, I need deeper penetration, I'll select 6010 or 6011, and I'll still run straight down the joint with a small whip and pause motion. This usually gets the job done for me. I really appreciate you spending your time with me today, and please remember Blue Demon for all your welding needs. Thanks for stopping by, and we'll see you next time.